All right, calculus students, I'm excited. You should be excited because this is the last video of this whole set, which is great. All right, so the last thing we need to do is look at the derivative of log-based a of x. And now we know how to take the derivative of natural log, so we've already got a rule for that. That's not a problem. But we don't know how to do log-based a of x or log-based a of u. And so the first thing we're going to do is actually come up with an equation for log-based a of x in terms of natural log. So the first thing I'm going to do is actually just from pre-calculus, but it's a good review, so please watch. So step one is I need to get to this x. And so I've got this log-based a. And remember that the inverse of any log is its base. So step one is I'm going to actually take a to each side. So I'm going to take a to the power of both sides. And so what I'm kind of doing is I'm undoing that log. So what I'm going to do is I'm going to take a to the both sides. So that's a to the y is equal to a to the log-based a of x. And remember that a to the log-based a of anything is that thing, so I get a to the y is equal to x. Okay, so now what I need to do, step two, and again this is just kind of from Algebra 2 or pre-calculus, is now I'm going to take the natural log of both sides, because I want to get this in terms, I want to get my x in terms of natural log, because I do know how to differentiate that. So if I take the natural log of both sides, I get the natural log of a to the y power is equal to the natural log of x. And then this y I can bring out front, and so I get y natural log of a is equal to the natural log of x. Now if I solve for y is equal to natural log of x over the natural log of a. Well, if I look at what my y is originally, y was equal to log-based a of x. So I'm going to put this in down here, and I get that log-based a of x is equal to natural log of x over the natural log of a. And this is probably something you recognize from Algebra 2 and from pre-calculus. Okay, so this is actually what I'm going to use to develop my rules for differentiation. So if I want to find the derivative of log-based a of x, the first thing I'm going to do is use this rule, that log-based of anything is the natural log of that thing over the natural log of the base. So I'm going to go back up here, and I'm going to rewrite this as the derivative of the natural log of x over the natural log of a. Well, remember that natural log of a is just a constant, so I can pull out a 1 over natural log of a, and if I do so, then I get 1 over natural log of a times the derivative of natural log of x. And now I know what the derivative of natural log of x is. It's just 1 over x. And so then I get that the derivative of log-based a of x is just going to be equal to 1 over natural log of a times the derivative of natural log of x, which is 1 over x. And there you go. And if you have if your base were e, then you have 1 over natural log of e, which is 1, times 1 over x, which would just be the derivative of natural log of x. So this agrees with our other rules. Okay, let's do a more general rule. Okay, so the more general rule, kind of using the same technique, is the derivative of log base a of u is going to be equal to 1 over natural log of a times 1 over u times u prime. So if you look at this, it's kind of similar to the derivative of natural log of u, which would just be this 1 over u times u prime. The only difference is you have this 1 over natural log of the base in front of it, for the reasons that I described on the previous slide. And then similarly to the derivatives of natural logs, I can also write the derivative of log based a of the absolute value of u is the same rule. It's 1 over natural log of a times 1 over u times u prime. For the same reasons that we have the same rule for the derivative of the natural log of the absolute value of u. Okay, so let's do a couple examples of this. And incidentally, there's no rule for integrating this, so you only, I mean there is, but not in this class. So there's, you only have to worry about differentiating this. I mean, to integrate it, if you were to integrate like log based a of u, just in case you ever do see it, then you just rewrite it as natural log of u over natural log of a times du, and then you could pull out that natural log of a and just get it in terms of natural log of u. But there's no homework problems like that. And but just in case you ever see it. Okay, next. All right, so let's do 2 quick examples, and then we're done. All right, so first example is, let's say I have y is equal to log based 8 of the square root of x. Okay, and I want to find the derivative. I want to find f prime. Okay, the first thing to do is, remember, just like with natural logs, use the properties of logs. So here this is really log based 8 of x to the 1/2 power, and I can still pull that 1/2 out. So always use properties of logs to get this into a form that's easier to differentiate. So that's y is going to be equal to 1/2 log based 8 of x. And the rule is the derivative of log based a of x is equal to 1 over natural log of a times 1 over x. And if you don't remember that, just the key thing to remember here is that log based a of anything is equal to the natural log of that thing over the natural log of the base, because that's where we're getting all of this. Okay, so here my y prime then is just going to be equal to 1/2 times 1 over the natural log of a, so that's 1 over natural log of 8, times 1 over x. So probably a nicer way to write this would be y prime is equal to 1 over 2 natural log of 8 times x. All right, one more example. And that example is, let's say we have f of x is equal to log base 13 of the absolute value of cosine of x. Okay, so the rules for these is the derivative of log based a of the absolute value of u is equal to 1 over natural log of the base a times 1 over u times u prime. Okay, so here u is equal to cosine of x, and du is equal to minus sine of x. So my derivative just becomes f prime of x is equal to, looking at our rule here, 1 over natural log of a, so in this case a is 13, so 1 over the natural log of 13, times 1 over u, so 1 over cosine of x, times du, which is minus sine of x. So f prime of x becomes minus sine over cosine, which I know is minus tangent. So it's going to be minus tangent of x over the natural log of 13. And that's it. So you are armed and prepared for getting all the homework done. And I shall see you this week at the optional review sessions if you come in. All right, have a good rest of the break.